Good evening once again. We are working on center of mass. So many different varieties of problems. Okay. So towards it, right. Projectile motion and center of mass. It's not using center of mass. Projectile motion and center of mass. It's not going out. Okay. Projectile motion and center of mass. So let us read this problem. A projectile of mass 5 kg in its course of motion explodes on its own into two fragments. Usually what we do, projectile motion, we write like this. We have a projectile here, you throw it goes like this, it falls here. The mass does not change, right? But unfortunately, projectile motion, one fragment of mass 3 kg falls at 3/4 of the range of the projectile. That means definitely it is not falling here. It should have been fallen from here. I do not know where does it fall. Let me assume. Okay, this was the mass, the initial mass when it was thrown. When it came here, okay, so it exploded. So what happened? One particle, it fell here at 3/4. The other particle, it went here and fell somewhere. Okay, let me, where do we assume it fell over here? Can we assume here? Are chalta hai. We'll assume here. Okay. Okay, a particle of mass 5 kg. So this is 5 kg once again. Explodes on its own into two fragments. One fragment of mass 3 kg, 3 kg. So this small fragment falls 3 kg over here. The other fragment of 2 kg falls somewhere. Okay, falls somewhere. Let me assume it's falling over here. 2 kg is falling here. I do not know. It may fall here, or it may take a path like this and fall over here. Now, first we need to reason this. Okay, and then we will go for the other ones. Okay, it may fall here. Now, where does it fall? First question. See, if it was 5 kg, it can fall here. It's able to carry the only force. Why does the projectile fall? First simple reason is that gravity is pulling it like this. You gave some energy. If gravity was not there, it would have gone straight like this, right? Because of gravity, what happened? It started bending like this, took a trajectory like this, and finally it fell here at 5 kg. Now, while it is going upwards, suddenly 2 kg mass has been removed, exploded, which means the 2 kg mass is ejected, and as a result of it, where will it fall? Lighter mass. Lighter mass, will it fall here? No, definitely not, right? So this will fall over somewhere over here. Okay, then you can ask me the question, why 3 kg falls below the range, right? This is my range. This is my range. Okay, so why does it always fall here? Because he has already given falls at 3/4 of the range of the projectile. I have not chosen it. Okay, he has chosen it. The problem has chosen it. Okay, so therefore, this value he has given to you. This value is given to you, 3r/4. So which means now what we need to do? Okay, so this our estimation that the particle falls here is incorrect, right? Where does the particle fall? Particle falls at this point. Let us say it falls at this point D from the 5 kg mass. I hope you are understanding the problem. Let me repeat the problem once again. I have a mass of 5 kg, which is a projectile. Let us say it's an atom bomb. Okay, so while it is going upwards, this bomb explodes into two parts. One of these parts falls over here, which is 3/4 of the range. Where does the other part fall? That's a simple question here. So towards it, we need to find a solution. Now, how do we find it? Once again, center of mass. Now, when this, see, now what happens to center of mass when the particle is going here? The center of mass travels with the same point. This is in accordance with one of the slides that I had shown earlier. Let me show you that slide. See here. See the configuration which this person throws the bottle, it keeps on changing over here. It changes its direction every time. But fortunately, after a long while, you see, okay, this particle, the center of mass always goes in the same projectile, right? Same range. So therefore, what we account, whether it is an extended system or a small system, this trajectory, we write it as a function of the center of mass only. Now, with this logic, let me come back to this slide once again. Right. So you threw a particle, it exploded here. Now, what will happen to center of mass? Center of mass remains the same. Remains the same means what? Which means the path taken by the 5 kg particle and the path taken by the center of mass will remain the same. That's what I meant to say. Okay. Let me write it down. Path taken by the 5 kg mass or path taken by the center of mass remains the same. Because why does it remain the same? Because no other external force is acting. Why did the explosion happen? The explosion happened only because of the internal forces here. Okay, gravity is an external force always. Okay, whether the particle was together or whether the particle was different, gravity is always same. But if you look at the center of mass, the center of mass happened. Sorry, the explosion took place. The explosion took place because of the internal force. The center of mass should not change, right? Which means the center of mass will always fall at this point. Which means the clue has already been given to you. The 3 kg mass is located here. The 2 kg mass is located somewhere over here. The center of mass is at this point, and the distance here with respect to 3 kg is seen to be r by 4, and this is equal to d. Why this is r by 4? The reason is because from here to here, this value is equal to 3r by 4, which is given to you. So the whole thing here is range, right? This is my OA range. Okay, from 3r by 4 plus x is range. So this distance is r by 4. Now what you need to do? Rest is quite simple. Now what you do is choose this as your origin, right? Choose this as origin. If this is your origin, then what we can do is we can say that, let us say this is m1, this is m2. Then what do we say here? m1 into r by 4, m1 into r by 4 is equal to m2 into d. How do I do that? Because if I choose this as origin, I know that xcm is equal to m1x1 plus m2x2 divided by m1 plus m2. This already you know, right? So therefore, this x1 is negative, x1 is negative here. x2 is positive. What is xcm? Origin 0, 0, right? So this point is 0. So I will put this 0 and then I will put this negative minus m1 into 3r by 4. R by 4. R by 4. The coordinate is already known to me. R by 4 plus m2 into x2 should be equal to so much, or m2 x2 equal to minus m1 into r by 4. That's what I've got. Now plug in the values of m1 and m2. What is m1? 3 kg. 3 into r by 4 should be equal to what is m2? m2 is 2 kg divided by d into t. So therefore, d should be equal to 3r by 8. Okay, it's very simple. What did our student do? Student response was something like this. He took 3r by 4, 3 into r by 4. What is 3 into r by 4? What he has done is, no, sorry, this is not the way how he has done. I show you what he had done. He had taken 3 kg multiplied by 3r by 4. 3r by 4 should be equal to 2 kg multiplied by x. He did something like this and finally got an incorrect answer. Okay, this is what you call as a deadlift problem. Okay, deadlift problem refers to you have a set of equations. You just take up any equation that you need and finally arrive at an answer, which is incorrect. Now, okay, we have still not solved the problem here. Where will the other fragment fall? And when you ask this question, it is with reference to, you have to mention very clearly where will it fall. If you just write d equal to 3r by 3, d equal to 3r by 3 will refer here. 3r by 8 will refer to somewhere over here. It will be somewhere over here, which would be incorrect. Okay, so you have to mention that the second 2 kg fragment will fall at a distance of 3r by 8 from the center of mass. You have to mention like that. Or you have to mention it will fall at a distance of r plus 3r by 8, which is equal to how much? 11r by 8 from the origin. Okay, this was a JEE problem earlier. Okay, so you have to either mention like this. So there are 4 options given. I have not put the 4 options over here. So this is the way how you need to mention. So one of the options was 11r by 8. So this is your answer. I hope you understood this problem. And if you have any other doubts regarding such kinds of problems, you can always mail me up or put me those comments in the comment box so that I'll be happy to share with you. So if you like this video, do share and subscribe to my channel for more updates of this sort. Thank you, friends, for watching.